Good day everyone. In lesson 1, we have seen what is relation and the types of relations. Hope you remember. In that, I taught you 3 important types of relations: reflexive, symmetric and transitive. Reflexive means what? Each element in a given set will be related to itself. That is called reflexive relation. Now let me give you 2 examples of reflexive relation and 2 examples of relations which are not reflexive, so that it will be clear to you, right? Now you consider factor of and equal to. Any number is a factor of itself, isn't it? 5 is a factor of 5. 9 is a factor of 9. 8 is a factor of 8. So, factor of is a reflexive relation. Equal to. Any number is equal to itself. So, equal to is a reflexive relation. Let us consider greater than. Can you say 6 is greater than 6? Is it possible? No. So, any number cannot be greater than itself. So, it is not reflexive. If you consider perpendicular, can a line be perpendicular to itself? Never. So, perpendicular is a not reflexive relation. So, you have to think more examples of relations which are reflexive and which are not reflexive. Okay. Then let us come to symmetric. What is symmetric relation? If A is related to B, that implies B is related to A. We call that relation as symmetric. You consider perpendicular. If a line AB is perpendicular to a line CD, you know CD will be also perpendicular to AB. So, perpendicular is a relation which is symmetric. You consider congruent to. Let us take 2 triangles, ABC and DEF. If triangle ABC is congruent to triangle DEF, definitely triangle DEF is congruent to triangle ABC. So, that is symmetric relation. Now, you consider the relation brother of. Supposing A is a brother of B. B can be a brother, but B can also be a sister, isn't it? So, if B is a sister, then in that case, the relation is not symmetric. You consider lesser than. You know, 4 is lesser than 6. But is 6 lesser than 4? No. So, lesser than and brother of, they are examples of not symmetric relations. Now, let us move on to transitive. You know, transitive relation means if A related to B and B related to C, that implies A related to C, you call that relation as transitive. You consider greater than. Now you know 6 is greater than 4. You know 4 is greater than 1. And you know 6 is greater than 1. This is A, this is B, this is B, this is C. So A is greater than C. So greater than is a relation which is transitive. You consider multiple of. You know 64 is a multiple of 16 and 16 is a multiple of 4 and 64 is a multiple of 4. So, multiple of is a transitive relation. Now, let us see 2 examples of relations which are not transitive. Let us take the same case perpendicular. Now, you consider this line AB. You consider this line CD. Now, you know AB is perpendicular to CD, right? Now, you consider another line EF. Now, CD is perpendicular to EF. So, AB perpendicular to CD, CD perpendicular to EF. But AB and EF, they are parallel, they are not perpendicular. So, it is a relation which is not transitive. Now, you think square root of. 2 is the square root of 4. 4 is the square root of 16. But 2 is not a square root of 16. So, square root of is a relation which is not transitive. Hope you are now clear about the 3 important types of relations. Like this, you have to think of many examples, okay, which are reflexive, which are not reflexive, which are symmetric, not symmetric, which are transitive, not transitive. So, if you analyze like that, you will be very clear about the 3 types. Now, one important thing I want to tell you before going on to the sums. Generally, if you want to prove anything in mathematics, you have to generalize it and prove. Don't give an example and prove. That's wrong. If you want to disprove anything, you can just give one example. If you disprove it, then you can take it as you have disproved it. Okay? Will you remember this? This is a golden rule. Proof means generalization. If you want to disprove means you can go for example. Okay? Now let me teach you an example sum. How to prove a relation is an equivalence relation. Okay? Let us take this sum. Let R be a relation defined on Z. You all know Z means the set of integers, positive as well as negative. Okay? Now, R is equal to A comma B such that A comma B belongs to Z. That is, both the elements belong to the set Z. And A minus B is divisible by 5. This is your rule of relation. A minus B is divisible by 5. Now, there are two parts of the question. The first one is, you want to prove that R is an equivalence relation. And the second part is, find the set of all elements related to 1. Now, let us concentrate on the first part. That is, we want to prove R is an equivalence relation. You know, equivalence relation means a relation which is reflexive, which is symmetric, and which is transitive. You call it an equivalence relation. So now first let us prove R is reflexive, R is symmetric, and R is transitive. Generally, in the chapter relations, many students, they know that the relation is equivalent, but they don't know how to write the proper steps. Okay, so I will explain to you in detail how to write the steps. So first all of you write the definition. That is, if R is reflexive, symmetric and transitive, R is an equivalence relation, because that definition will carry some mark, maybe half mark or 1 mark. Okay, write that. Then let us prove one by one. First let us write reflexive as the side heading. That is, we are going to prove R is a reflexive relation. Now when you consider something, you should be concerned about the step, that is the set. Here Z is the set. Okay, what is the rule of relation here? A minus B is divisible by 5. So both these things should be clear. So now I will write A comma B belongs to Z. Okay, then actually the R is A minus B is divisible by 5. So I am writing the set, I am writing the relation. A minus B is divisible by 5. Now in reflexive, it should be the same element, isn't it? So I can't consider two different elements. So I will consider both as A. You know, A minus A, that is equal to 0. Whatever be the value of A, you know A minus A is 0. And 0 is a multiple, or you can say 0 is divisible by, both are same thing. But let me use the same word, is divisible by 5. So now R is reflexive over. So we have proved that R is reflexive because A minus A is 0, which is divisible by 5. Now let me move on to symmetric, right? Now in symmetric, if A related to B implies B related to A, then you can say R is symmetric, right? So I will write, if A related to B implies B related to A, R is symmetric. This is the definition for me. Now, it is given already, A minus B is divisible by 5. That is given. Now I have to prove B minus A is divisible by 5. So now I can write A minus B is equal to some 5k. That is some multiple of 5. That k can be any number, positive or negative. Now I will take a negation from here. So I can write minus of B minus A, that is equal to 5k. Or I can write b minus a is equal to minus 5k, or it is 5 into minus k, which is also some integer, isn't it? So it is a multiple of 5, or it is divisible by 5. So now I know b minus a is divisible by 5, right? So now I know R is symmetric. So now I have proved R is reflexive and R is symmetric. I have to prove one more, that is R is transitive. Okay. Let us move on to transitive. Okay. What is transitive? If A related to B and B related to C. Okay. If these two implies A related to C, you can say R is transitive. This is the definition. If A is related to B and B is related to C implies A related to C, you can call R is transitive. So now I will write A minus B is divisible by 5. Okay. Then B minus C is divisible by 5. Right. So what do you mean actually? I can write A minus B is equal to 5 into some constant k. I can write B minus C is equal to 5 into some constant p. Right. Now I will add these two. I will call this 1. I will call this 2. I am going to add 1 and 2. So what will I get? I will get A minus B plus B minus C is equal to 5k plus 5p. Minus b plus b will get cut. So here I will get A minus C, that is equal to 5 into k plus b. So A minus C is some constant into 5. That means it says A minus C is divisible by 5. Therefore, R is transitive. Okay. Now let us write the conclusion. Since R is reflexive, symmetric and transitive, R is an equivalence relation. So the first part is over. We have generalized, we have proved. Now there is a second part. You have to find the set of all elements related to the element 1 in your set. Now you know the rule of divisible, that is the rule of relation here is A minus B is divisible by 5. That means whatever be the element given, you have to add 5, you have to subtract 5, so that the resulting thing will be definitely divisible by 5. Do you follow? So that is a simple thing. So that A minus B will be divisible by 5. Now let me give you an example now. Now I take 1, okay. With this, I will be adding 5, so I get 6. So this is my A and this is my B. So 1 minus 6 will be minus 5. So it is divisible by 5. Okay. Now I can add 5, or I can add 2 into 5, that is 10. So now 1 is A and B is 11. So I know 1 minus 11 is equal to minus 10. So that is also divisible by 5. So I can add 5 or I can add multiples of 5, so that the resulting A minus B will be divisible by 5. Similarly, I can subtract also, isn't it? So now what I can do is 1 minus 5, that is minus 4. This is A and this is B. So A minus B is 1 minus of minus 4, which is 5. So that is also divisible by 5. Come to the next one. 1 minus 10. Okay. So 1 minus 10 is minus 9. This is A, this is B. So 1 minus of minus 10, which is 10. So now I can go on adding multiples of 5. I can go on subtracting multiples of 5. Okay. So that A minus B will be divisible by 5. So how can I write the set of all elements? So the set of all elements related to 1, that will be, okay, I will put a set bracket. So let me go from the negative side, that is I have got now minus 4, I have got minus 9. Like this I can get anything. So I will start from the lowest. I will put some dash dash. I will write minus 9, minus 4. Okay, I will write the b values. So minus 9, minus 4, dash 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 I can have. In the plus side I have got a 6, I have got a 11, then like that I can put dash dash. So these will be the set of all elements which are related to the element 1. So whatever be the element given, if they give you 2, you have to add 5 with it, you have to add 10 with it, you have to subtract 5, you have to subtract 10. So this is the rule. So have you understood how to write the steps properly for this sum? So let us see in the next lesson few more different examples. All of you subscribe to the channel and click the bell icon if you want to get notification of further videos. Thanks for watching.